In this video, I'll be explaining the solubility of biological compounds. There are 3 biological compounds categorized by their water solubility. Now, the first one would be hydrophilic. That means that it's water loving. These types of molecules are attracted to water, therefore they are going to dissolve in water. And that can easily be shown by putting something like sugar, something hydrophilic, in water, mixing it up, stirring. And we all know that this dissolves, so I don't need to keep stirring. Next would be a hydrophobic molecule. Hydrophobic molecules are water hating, or they're not attracted to water. We've all tried to shake up some salad dressing and put it on our salads to have a nice little snack. And we know that no matter how hard we try, oils just won't dissolve in water because they're not attracted to water. They hate water, they're hydrophobic. The third type of molecule is very interesting, and that's mostly what the video is about today. So, these molecules are called amphipathic molecules. They're composed of a nonpolar, water-hating, hydrophobic region and a polar, water-loving, attracted to water region. So essentially, an amphipathic compound looks like this. We have a polar head that will be attracted to water and a non-polar fatty acid tail. We all know oils, again, don't dissolve in water. So they're not attracted to water. They are non-polar. So the cool thing about amphipathic compounds is that they're all around. Our body actually is composed of so many, because what our cell membranes are made of, our cell membranes are amphipathic compounds, and they look like this. They are phospholipid bilayers created by 2 rows of these amphipathic compounds, with the polar heads facing out and away and the tails facing in towards each other. These membranes are why certain molecules, proteins, water, electrolytes, anything can pass in or cannot pass in and out of a cell. So, how do I word this? Amphipathic compounds, because they have a region that is attracted to water and a region that is not attracted to water, when they are faced with water, in a situation with water, they still won't dissolve. But the polar heads will be attracted to the water, and they'll arrange themselves basically like this, with the water here. Use your imagination. So, and they'll form monolayers, or a layer, not a bilayer, but a monolayer, one layer, of all the polar heads facing the water and the tails facing away. Because the polar head is attracted to water and the tails are not. However, tails are attracted to oil. Now this is where we bring in the example of what an amphipathic compound is, which is soap. Soap is a great example of an amphipathic compound. Soap does not dissolve in water. Actually, when you put it on in a sink full of water when you're doing your dishes, it doesn't dissolve within. You can see the bubbles and the soap sitting on top of the water. Now, this is what happens when soap is faced with a water situation and an oil situation. Think of when you're in the shower, you're washing your oily, nasty, greasy hair, or you're scrubbing your skin. The goal is, in this situation, is to rid your body or your hair of the oils. What soap does is it'll arrange its polar, water-loving heads towards the water, because the fatty acid tails are attracted towards the oil. So, what happens when you're washing yourself? The water is attracted to these heads, and the oil being attracted to these tails. As the water washes over it, it'll pull away the soap, and with the soap will come the oil. That's how soap works. And it doesn't just work on your skin, it also works on clothes. So our real world example today will be with a t-shirt with greasy, nasty bacon stains on it because I'm a meat eater. So if my lovely cameraman will come this way. As you can see, maybe a little hard to see because this is a gray t-shirt, but this t-shirt has some oil grease stains from a hydrophobic substance. Grease, oil, you get it. Today, we're going to get the oil out of the shirt using soap. Dawn works great. You've all seen those duck commercials with the oil on it. So cute, and it works. But it also works on t-shirts. So if you don't have a bacon shirt like me, now you know this little trick to get the oil out. We're gonna throw this in the washer. Why don't you come with me? So now we're going to demonstrate what I talked about downstairs by washing this soap and the oil out. There's also soap in the washing machine too, but the dish soap is really what does it. Now I'm gonna put it in the dryer. We'll see you back here later. All out of the dryer, and we can see that the stains are gone. So now you know if you ever get grease on your clothes to get it out with dish soap. Thank you for watching. Bye.